Hey, for the latest news, go to SCTE.org for standards, training, certification, events, even membership. Everything you need to know, SCTE.org.
Particularly as America is really intent on building out a lot of the underserved areas in the country, with what we consider to be broadband services, whatever your definition of broadband is, whether it be wireless or wireline. But one of the ways that I see a lot of companies doing this is through the use of PON or passive optical networks. And the use of PON and the different variations of PON, right? Because you mentioned here there's a bunch of different ones: EPON, GPON, XGS PON, whatever. All of them fit into that FTTX or FTTH sort of bucket, fiber to the prem or fiber to the home. But the use of fiber in the passive optical networks is obviously super important. And of course, then all of the interconnects as you start to build out these passive optical networks and how you connect subscribers to it is a big topic of conversation. So, yeah, why don't you run us through that one?
Yeah, so PON, passive optical networking. This is kind of in some ways, a competing architecture to DWDM. It's a much more cost-effective architecture, I believe. So basically, some of the terms you'll see here, the OLT, that stands for optical line terminal, that's going to sit in your head end or your POP or wherever. Then once it leaves the facility, it's all going to be on a single fiber, and it's going to hit an optical splitter. And so the splitter in itself, some might mistake for a MUX. They look very similar, but operate very differently. So basically, the splitter is just, what you see on this first one here. It splits off into 4 different fiber lines. Each one of those fiber lines is getting the exact same optical signal from the OLT, and it will ultimately end up hitting each of those homes. So if you have a 10 gig PON network, each one of those homes is, in theory, receiving 10 gigs of data. The caveat is the ONU or the ONT, the optical network unit, optical network terminal at the home, is listening for very specific parts of the signal, and they're all calibrated to specific basically timing portions. It's like TDM, time domain something
Multiplexing.
used here. Yeah.
Yeah. So this is where it gets really interesting, right? Because we do have one optical signal, which is pretty similar in some ways to what we do on the coaxial side of the world, where we have our broadcast signals that are sent, directionally to all of the customers in a particular service group area, and they all receive those same downstream signals. But where this is interesting is optically, all of the host terminals or the ONUs, ONTs are listening for a message that's just for them. So it's not quite the same as broadcast, but it's interesting how that works. And then the size of the splitter is important because that goes into your link loss budget, right? So your transmitter, your OLT, has a fixed output. And then the number of splitters that you can put into that passive optical network ultimately factor into your link loss budget, so that you still have, your minimum optical receive levels at the receive device from a receiver sensitivity standpoint. So, there are some similarities between, the last mile of a coaxial passive network and the passive optical networks, but with some very key differences. But this is a big technology that's I think coming to more and more places as we build out the edges of the traditional HFC networks to reach more customers with broadband services. And one of the interesting things that has happened, at least for us, not to talk about Comcast specifically, but the ability to take that OLT and put it into a very small form factor and actually hang it in a node housing out on the strand rather than having, these large OLT, pieces of infrastructure. They've gotten really, really small to be able to virtualize sort of the core network side of that OLT and then, transmit it long distances to an edge device and then be able to service PON networks off the edge of that is really making PON even more effective in, building out the peripheries of some of the HFC plants.
Yeah, and it's actually pretty amazing because that's going to be really helpful in sort of the migration away from coax into PON. Is you're going to, by miniaturizing it by how much they've been able to, because I think of like Nokia's ISAM setup. You could have a 22 RU OLT sitting in a head end. I don't think the OLT that sits out in the field is going to have necessarily the same capacity, but by allowing it to kind of interop with the RPDs that are already out there, it's going to save you guys a ton on infrastructure.
Yeah, so obviously the service groups that we can feed off of one of those remote OLTs is much smaller, to your point. But it does allow you to distribute that infrastructure into smaller housings out in the field that'll hang on the strand and still extend the reach of your plant over that passive optical network. So a lot of really cool stuff happening in this space, and a lot of conversation around rural broadband these days.
Yeah, and the data rate that they're able to provide is absolutely mind-blowing too. A lot of operators are already at 10 gig with this. They're already planning on 50 gig and 100 gig PON offerings. Still a couple years away, but I mean, it was just a couple years ago I was getting 16 megabit service. I'm now up to half a gig. So what do you even do with all that bandwidth?
I don't even know. But hey, I think on the next slide, there's some standards around, PON transceiver hardware, whether it be GPON, EPON, XGS-PON, the different distances and data rates. So looks like all of these are really through single mode fiber with SE simplex connectors, and fairly standardized wavelengths, right, on the upstream and the downstream on some of these PON platforms, but slightly different options in the SFP form factors, right? Whether they be SFP, SFP plus, DD, or XFPs in support of the different PON architectures and reaches. So that's a useful slide too, as you're building out your PON networks to understand, well, first of all, what generation of PON are you building? Is it EPON, GPON? What is your link budget? And then that'll ultimately determine what form factor that you'll need to use in that particular application.
Yeah, and the thing I want to point out too with the link budget piece, and SFPs and SFP pluses early on in the presentation showed like a max distance. There was an actual, meters or kilometers value listed there. When you get to PON optics, really have to talk about the max distance in terms of the link budget specifically. The splitters eat up a lot of the optical link budget. Something like, now correct me if I'm wrong, but a 1x4 splitter takes about 3 dBm. A 1x8 takes 6. A 1x16 will take 9. A 1x32 will take 12. A 1x64 will take 15 dB of optical signal away. So you can see pretty quickly when you start scaling it, you lose a whole lot more link budget. So that's why you see some pretty hot, quote unquote, hot optics here, where C plus GPON has a 35 dB link budget. It's
Yeah,
not very typical. I'm sorry.
I had to refer to my data book for the losses in the optical splitters. But yeah, to your point, the transmitter power is relatively fixed, right? So when you're designing and thinking about your PON network, it's really how many homes do I have to service inside of this geographic footprint. That then determines the size of the optical splitter that you need, which then you can sort of back into how far your optical link is, because that's the other part of the optical link budget that has to be considered. So a lot of different parts in understanding that the size of your splitter network, how that contributes to your optical link budget, and then what that does to your distance limitation. So all important parts.
Yeah, and the receiver or input saturation power is at play with PON optics as well. So if you have a splitter with 32 customers and that first customer is right next to the splitter and the last customer is 50 miles down the road, probably not going to be able to connect them because you're either going to come in too hot for the house that's right next to the splitter or too cold for the house that's 50 miles down the road.
Right. So lots to think about. Yorick, I appreciate all of the material that you've put in front of us today. It's a lot to digest in one sitting. So I appreciate all of the material, all of your time and expertise in sharing this with us.
Yeah.
So thank you to Precision Optical Transponders for partnering with us today on this version of Tech Talk and bringing us this video with the partnership of the Penn Ohio SCTE chapter. So that's all for today, folks. Appreciate you joining us. If you like what you saw here today and you've learned something, don't forget to like and subscribe, and check back to Penn Ohio SCTE chapter's YouTube page for more training like this one.